What's up, YouTube? Thanks for tuning in to Mr. Wolf's Algebra 2 class. Hope you learned something today. It's going to be super exciting. Smash the buttons down there to like and subscribe so you don't miss any of my new content coming out. Is that what you're looking for, Jack? Get my YouTuber on. All right, now to the actual notes for today. Quadratic inequalities. Quadratic parabolas, inequalities, less than, greater than stuff. Again, I don't think you've done both of these things together, but you've done them both separately, and if you understand them separately, it's easy enough to kind of put them together. There are two different types, and so I'm going to put like a Roman numeral 1 by this first half of the page, and we'll put a Roman numeral 2 down by the second half in a moment. And it feels a little bit weird because the Roman numeral 1 is 2D graphs, like an XY graph. That's why you see the graphs there. So Roman numeral 1 is 2D, I think is easier. Roman numeral 2 is a one-dimensional graph, also known as a number line. So they're both quadratics, but really only number 1 is a parabola, because number 2, or Roman numeral 2, there's not any y's in that second set of problems. So we'll get there in a minute. I think it's easier to do the one with the y's because you're more used to it. So there's not much room to write steps down here, but graph the parabola. So we know how to do that. And maybe it's in vertex form, maybe it's not in vertex form. So like on these, we'll have to do negative b over 2a, and that's probably enough because then you can do the 1, 1, 2, 4 stuff to graph it. So you know how to graph the parabola. And then the rest is the inequality stuff. So we'll be thinking about solid versus dashed. So when do you dash versus when do you solid? Heard lots of different things, but I think they were all right. Solid when it's equal to, dashed when it's not, right? Because equal to means you want to include the line, so you make it a solid line. If there's not an equal to, like this one, like number 1, you don't want to include the actual parabola, so you do a dashed line to indicate you don't want to include that. And then there's where to shade. We can still think about over versus under. When would you shade above? Maybe I should say above rather than over.
Shade inside the parabola.
I'm glad you said that. Don't ever say inside versus outside the parabola. Shade above or below. Because above or below goes with the inequalities. Above is greater than, below is less than. You can't match up inside versus outside the parabola. Because of the negatives. So instead think over versus under, above versus below. Okay, so you already know the pieces. Let's just put it together for this one. X squared plus 4x plus 3. So the x coordinate of the vertex, negative b over 2a. So negative 4 over 2 times 1. So that's my x coordinate. How do I get my y coordinate? Plug it in. And I'm just going to switch to y equals, and I just know that this will be dashed, and I'll shade above when I get there. Negative 2 squared plus 4 times negative 2 plus 3. So 4 minus 8 plus 3. Negative 4 plus 3 is negative 1. So we'll go to negative 2, negative 1. There's my vertex. And from there, I can just do the 1, 1, 2, 4, 3, 9, and so on points. Again, when I do those points, you do those from the vertex. From the vertex. So over 1, up 1 on either side. And then 2, 4, again, you do 2, 4 from the vertex. There was a few people in that last test that did 2, 4 from the 1, 1 point. You know, it's like, no, go back to the vertex, and from there go over to up 4. And then before I sketch that in, I need to be careful. Is this a solid or a dashed one? Dashed. It's dashed. So, I could have done 3, 9, I guess. That would put me at... So, I don't know. I feel like it's always tricky enough to draw a nice parabola. Now you have to draw a nice parabola dashed. And then am I shading above the parabola or below the parabola? Greater than means above. So there's our picture.
All fruits have seeds, right? Tomatoes have seeds, but also that's why they're not.
All right, what makes number 2? What makes number 2 different? It's equal to, so that'll mean solid line. It's flipped. Why is it flipped? The negative sign. And where are you going to shade? Below. Okay, why don't you try number 2? So yes, the vertex is ugly, but the x-coordinate's 5 halves. So you plug in 5 halves, you get negative 25 fourths plus 25 halves minus 4. Common denominator of 4. So that's not too bad to figure out. So I end up with 25 minus 16 is 9. 9 fourths. So that would be 2.5 comma 2.25. 2.5 comma 2.25. Jack, did I overhear you say you were going to do something else?
I said that should be illegal.
No, but there was a different method you were going to try.
I said I couldn't factor, and I realized you couldn't factor because whenever you take up the negative.
Oh, it won't factor?
No.
Bummer, that was a good idea.
I didn't see the x was negative at first. 4 and 1.
Hey, that'll factor. If you take the negative out.
Yeah.
Right? Because x minus 4 and x minus 1.
Yeah.
So x equals 4 and x equals 1. Which is a great strategy because now you've got 2 more points. Did I do that right? X squared.
Yes, you did that right. Yeah, I just did.
So there's one. Well, and I should know I get it right when I put it on there and see that it's symmetric across the vertex.
I like that.
So, I don't know. Is that easier than doing 1, 1, 2, 4 from a weird point?
Sweet. Oh, wait.
That's up to you. So now I've got enough points. I'm satisfied with that. I mean, I guess you could say it looks like a triangle, but you know it's a parabola. So as long as you can sketch a parabola onto those 3 points. Over 1, down 1 wouldn't be too hard to do. Looks kind of funny maybe, but... And if you only did 1, 1, 2, 4, you wouldn't get the 1 and the 4. You wouldn't land at the x-intercepts. You'd have to factor to get those. So you could do either one. You could do 1, 1, 2, 4 from a weird spot, or you could factor and get some nice points. There's one other nice point I could get.
The y-intercept.
A y-intercept
It's just negative 4.
is negative 4. 1, 2, 3, 4.
And you can just go across from that.
And then I could mirror that across. So that would be right there because of axis of symmetry. So you have options when you're graphing. You can always do the vertex. If it's in vertex form, that's preferred. Negative b over 2a is a different way to go. And then factoring to get the intercepts is a different way to go. And you can combine those in however much you want to do. Okay, we said this one is a solid line. And we're shading below.
Fruit berries are fruit.
Okay, hold off on the berries and fruit conversation for a moment. So again, you know how to graph parabolas. You know how to graph inequalities. Now you're just kind of putting the two ideas together. Ryan, do you see why I was cautious about on the inside versus outside the parabola?
Well, I was just trying to.
Okay, because both of these were inside, but one was greater than and one was less than. So don't do inside versus outside. Do above versus below. Above versus below. Okay, so that's the 2D version, which I think is easier. Now let's do the 1D version. Well, I mean, you'd think it should be easier because 1 is less than 2, right? So 1 dimension should be less than 2 dimensions, so this should be easy. There's only one variable. Here's the steps for this one. Set, well, there's not a y. Set equal to 0, just phrase it that way. So we'll find the zeros. That's just solving. So that's pretty easy. You know what? Let's work number 3 as we do the steps here. So we'll set it equal to 0. You could use the quadratic formula, but most of these should be rigged that you don't need the quadratic formula, because the quadratic formula is going to give you it's going to give you fine answers for these. But if you have to use the quadratic formula, it means you're going to get ugly answers, which is going to make the rest of this problem really, really bad. So most of these are going to work out nice, like x plus 8 and x minus 7. Okay, but those are the places where the quadratic is equal to 0. And then we want things to be less than 0. All right. There's 2 different routes to go here, and we are going to end up with interval notation. I think I'm going to do the route. I guess I'll show you both ways. The standard way is to take those zeros and put them on a number line. This way is good because it's also the method we use in calculus, so it's good to go ahead and get used to putting zeros on a number line. We don't want to include those because it wasn't equal to, so open circles. Remember this? Open circles versus closed circles. Now, how will I know where to shade? Do you know? How do you know to shade away?
Everything that's less than 2.
I don't know. Let's test.
Because it's less than.
No. Okay, it's not. That was with absolute value. Was the less than the gray tor? That's for absolute value. Let's just test the intervals. So let's test -9 and 0 and 8.
Wait, you can't do anything with 7. Because no matter what you do, that's going to be wrong.
If I plug in 7, I'll get 0.
But that's not less than. Oh,
that's why it's an open circle. So I know if I plug in 7 and -8, I'll get 0.
But any line you draw from 7 is just going to be wrong.
What do you mean draw from 7? No.
Well, 8 would. Because like 6 is not going to work.
Well, what do you mean not going to work? If I plug in 6?
6 is a less than.
Let's plug in 0. That's an easy one to plug in. If I plug in 0, I get -56 is less than 0. That's true. So I can shade that region. If I plug in 8, let's see, 64 plus 8 minus 56.
Oh, that's wrong.
And I mean, you only need to know if it's less than or greater than 0. So even if your math is a little off, 64 plus 8 minus 56, that's definitely more than 0. Even if you don't know exactly what it is, right?
16, right?
Let's see, that'd be 72. It'd be 16. But again, you don't have to come up with 16. As soon as you see that 64 minus 56, that's greater than 0. So this is not true. So I don't want to shade there.
What about negative 9?
What about negative 9?
No, because 81 plus 9.
Yeah, 81 minus 9 minus 56.
That wouldn't work.
That wouldn't work.
So it has to be that inner region.
So it's only the inner region.
But it's less than and greater. Irrelevant.
Irrelevant. Less than, greater, that's for absolute value.
So the only reason it worked here was the coincidence.
Correct. Because it would be easy for me to make that sort of the opposite answer.
So does that mean that x is... Wait. No, we already found it. Negative 8 always.
So anything between negative 8 and 7 will work in this inequality. Anything between negative 8 and 7 will work in that inequality. Let's try a different one. Let's try number 6. So job 1 is to find the zeros. So I'm going to factor out that negative just because that makes my factoring life a lot easier. And I'm going to set it equal to 0 to find the zeros, but know that eventually I've got to consider the less than stuff. So x plus 5 and x minus 4. So x equals negative 5 and x equals 4. Negative 5 and 4. Plug in negative 6.
So we're just forced to plug in.
Yes, you're testing an interval. And you can test any number in that interval you like. Usually 0 is the easy one to pick. And then greater than 4, 5 seems like the easiest thing to pick. But you could pick 6, 7, 8, 9, 10, or a million. Just seems like 5 would be the easiest.
0 doesn't work.
Just make sure you plug it into the original. And you plug in 0 or any of those. 0 does not work, right? Because you get 20 is less than 0.
So is it anything between there?
So that's right. That means anything in that interval won't work.
The 5 also probably.
Does 5 work?
Oh.
Negative 25
Negative 25.
minus 5
Yes, no, I like it.
plus 20 is less than 0.
No, equals 0. No.
I'm plugging it into the original.
You've got negative.
Got to plug it into the original. So yeah, that works. So we can shade there. And if I plug in negative 6, I get negative 36 plus 6 plus 20. That would work.
Wait, if it's on the other side, can you just automatically assume it's
Okay, there are some conclusions to be made with patterns going on here. So looking at those first two.
Would it be negative 25 plus 5?
On this one? No, because if I plug in 5, negative 25 minus 5.
Well, it is negative 5, so it'd be negative 5.
I'm not plugging in negative 5, I'm plugging in positive 5 to test this interval. Let's do another one then, and we'll see if we can come up with a pattern going on here.
Is the pattern?
Actually, let's do the pattern now before we do the next one. What's the pattern? What do you think is happening?
If there's like a negative on the x squared, does that change anything?
Yeah, but there's an easier pattern to see than that. Forget the problem, just look at the answers.
It's the where you shade.
Where you shade, what about where you shade?
Inside and the outside. What?
Okay?
So just test the 0.
So the shading is going to alternate. is the better way to phrase that. The inside or the outside is true, but remembering that it alternates will carry forward when you get to further math classes. So remember it that way, that the shading alternates.
What do you mean alternates?
So yes or no, yes, no versus yes, no, yes. So, okay, let's do the next one. Because Caroline asked a good question. Will it always do that? Like, oh, well, let's do number 5 and see what happens.
No, because we don't have one answer.
Okay, well, it does only have one answer. That's okay. So 1, this one's equal to, so I'll fill that in. Is there something special about that x equals 1? Have y'all used a name for that kind of root before?
It's a vertex.
Because like there's something different about it since there's 2 of them, right? I mean, they're both 1, but there's 2 of them. That's called a double root. Have you heard that term before?
Probably have.
Double root?
That sounds like a fancy way of saying it.
It's a fancy way of saying x equals 1 twice. That's exactly right. All right, so let's check 0, and we can check 2. This is an easy one to check. So if I check 0, 0 minus 0 plus 1, 1 is greater than 0. That is true. That is true. 1 is greater than 0. If I plug in 2, 4 minus 4 plus 1, 1 is still greater than 0. That's also true. Okay, so we'll go back and think about the pattern, but the first thing we see is this everything works. Negative infinity to infinity. So Caroline, there's the answer to your question. Does the alternating thing always work? No. But we can still use that rule, because if we know when it doesn't work, we can still use the alternating rule.
Doesn't work with one solution.
It doesn't work across a double root. It doesn't work across a double root. Why don't you try number 6, and then we'll go back and find some other connections here. You try number 6. Wait, what number are you checking?
2.
Oh, we're checking 2? Yeah.
Yes, that works.
36 plus 40.
0 and 2.
Yeah, 2 works.
Wait, does 2 work?
I got it works.
Did 0 work?
No.
0 definitely did not work.
So does that mean the other two?
That should mean, if we don't alternate, since it's a double root, it should mean this one doesn't work either.
2 does not work.
9 times 4 minus 48 plus 16 is less than 0. Yeah, 36 plus 16 is bigger than 48. Right? Even if you don't know the details. 36 plus 16 is bigger than 48. So that's a no. So it did not alternate across a double root.
So pretty much all we have to do is test 0.
So no solutions is the answer. Okay, so now I'm open to hearing some shortcuts that you think might work, right? And you said one.
Just test 0. You can always find it out.
Okay, so the suggestion is just test 0. And after you test 0, what are you going to do from there?
Use your brain to know the trends.
Okay, use your brain to know the trends. I'll like that. So either alternate or don't alternate, depending on what type of problem it is. I would say there's only one small problem with that, and you'd probably figure this out. If 0 was one of the zeros, you'd have to pick another number. But you are right that you only have to test one interval, because you can alternate from there, or not alternate from there. So find the zeros, put them on the number line, and then test as many intervals as you think you need to test. Maybe all three, maybe just one. I feel like a lot of people will test 2 intervals to kind of check themselves to make sure they're on the right track. But if you're feeling confident or you're pressed for time, then you test 1 interval and alternate from there. Karis, question?
Well, isn't it, the ones that are all less than, like, if one interval doesn't work, then the other one doesn't work? If you test the number on either side, they both don't work.
I can make a less than problem that makes those intervals not work. Yeah.
Okay.
Yeah. You're going to end up having to test an interval. That's going to be hard to get around. But you only need to test 1. Okay. There is another way that some of you might like. Do you want to see it?
No. Yes.
Okay, so some of you may want to ignore me.
Like on the homework,
What's that?
we could find the problem from the homework and then run this other way.
Oh, that's good. That's sneaky. That's sneaky. Let's do it. Let's do it. I like it.
Because it's the guard.
Thanks.
They have seeds in their.
Okay, so let's see. You want to do one from the homework the other way. Okay, 1 through 4 is kind of again, I think the easier ones, even though it's 2-dimensional, because you're used to graphing a parabola. So, Jack, you suggested one from the homework. You got one that you'd like? Got lots of choices there. Do one of the crazy ones.
Do 8, yeah. 8 or 11. Or 12. Or 7. I think 8.
8's easy?
Well, they're all pretty much easy.
11's got big numbers in it, but...
No, let's do 7.
7?
It's in the top.
7 it is. So, what should I do first on number 7? Move the stuff over, yeah. So, 2x squared minus 15x plus 25 less than 0. Now, because you end up on the number line with these, we almost never, I should have looked at the answers to make sure, I almost never give you ones that don't factor. Because if it doesn't factor, you have to use the quadratic formula. And if you quadratic formula something that doesn't factor, you end up with a really ugly number. And then you got to figure out where to put it on the number line and how to pick intervals. So, they should factor. 2x and x. Yeah, minus 5 and minus 5. Okay, couple things. No double roots. That means I don't have to worry about, does it alternate, does it not? It alternates because there's no double roots to worry about. 5 halves and 5, or 2.5 and 5. Yeah, this is a good one. This is a really good one.
Because 0 is not in the middle.
Because 0 is not in the middle. You would be surprised, maybe you wouldn't be, maybe you'll be the person who does it, but some of you want to always check 0, which is fine, but you better put 0 in the right spot. Some people will always check 0 and they always put 0 in the middle. Like, well, wait a minute, look at what's going on here. I'm okay if you check 0, but you better put 0 in the right place. I still think I want to check 0 in the original.
Oh, is that going to change?
No, you can still check it in this one. Either way, it should be the same. In fact, either way, I get 25 is less than 0, which is not true.
Oh, so what's the other?
We'll get there. So I can alternate from there. So this one's a yes and this one's a no.
That makes interval notation easy.
So interval notation, 5 halves to 5.
Oh man, we saw that one the other way. That's honestly like just gonna do pretty small.
Okay, the other way is what would this, like this thing is a parabola, yes?
You imagine if it was like on a big graph.
That's a great way to say it. You imagine that parabola. Is that parabola pointing up or pointing down? And you found the zeros of the parabola.
Shoot, that's kind of cool.
And you want to know where my parabola is below 0? My parabola is below 0 between, right? There's where it's below 0. So the other way gets you out of testing intervals. You still got to find the zeros. You still got to put them on a number line. You don't have to plug in if you know. Basically, all you have to know is it an up parabola or a down parabola? But plugging in 0 is pretty easy too. So either way. So if you like the alternate method, that's fine. But sketch the imaginary parabola on there. That way I'll know that you did it that way. And you're just looking for where that parabola is less than 0. But plugging in 0 is pretty easy too. Up to you. Do we want to do one more together? Because some of these look ugly. Yeah, might as well do a couple more together. You tell me. 11? 11 it is.
11. But he said that pretty much all factors. But still, it's 4x.
Oh, yeah, I know. I was looking to divide them all by 4, and that won't work. How about plus 49?
49 is a prime. Well, it's 7. Yeah, there's 7 times 7. It's a prime.
Well, it's got to be 7 and 7, because I'm pretty sure I'm not using 49 in there.
That would really count. So, why are we using 2 and 2?
Oh, yeah, because 2 times 7 is 14, and 14 is 14.
So, got to be 7 and 7, because 49 is going to make things blow up.
One has to be negative.
And it's minus 7, minus 7.
Yeah.
So x equals 7.
It's only 1.
Okay, but x equals 7 over 2. Hey, gentlemen, Preston, guys. It's a double root. What does that mean?
We're going to have either all solutions.
Maybe all solutions or no solutions. Maybe not. Let's see what happens here.
Oh, because equal to.
So 7 halves, double root, but closed circle for sure. And then check 0. So 69 is less than 20. Like, no, that's not true. Or 49 is less than 0. Also not true. So no, it's not going to alternate. So this one's also no. But it's not no solutions, because there's still a point there. So it's just 7 halves. So just 7 halves. Yeah, because, I mean, interval notation on that would be kind of weird. I'm not even sure what it would be. 7 halves in brackets. Like, there's your answer, 7 halves. Yes. The alternate method, parabola pointing up with only one root, it would be the vertex. If you find a double root, that means it's the vertex. And you want to know where it equals 0. Well, it equals 0 at 7 halves. Where is it less than 0? Well, it's never less than 0. It's always above the axis if you're using the other method, or the graphing method. You think we should do one more?
Why not?
Of course you do.
We should do one of the other graphs. Yeah, we should do it.
You know what? We should do number 13. We should do number 13. Cody, if you started number 13, do you know why I'm picking number 13 to do? It doesn't factor.
Oh, no.
Oh, man.
We can do the quadratic formula.
I can use the quadratic formula. Yep. X equals negative b plus or minus the square root b squared minus 4ac all over 2a.
Oh, that's another nasty answer though.
It is going to be a nasty answer.
Let's go make it square. Shoot, you can not be honest. Or we just stick with the nasty answer.
2 plus or minus,
That's 24.
that's 24, so that's not terrible. So 24 splits into
2 root 6.
2 root 6.
So it's just 1.
So 1 plus or minus square root of 6. Okay, that looks terrible. But for the number line, all you really need to know is which one's bigger than the other one. Well, I'm pretty sure 1 plus square root of 6 is bigger than 1 minus square root of 6. Open circles. And then I need a number in between 1 plus square root of 6 and 1 minus square root of 6.
We do 0. Is 0 in between those?
I don't know if 0 is in between there.
I think it is.
I think there's an easy number in between there.
1?
1.
It's just in the middle.
It's going to be right in the middle.
Oh yeah.
Because it's adding and subtracting.
Because you're adding and subtracting from what? So you can still check 0, but you better be sure you know where it lands.
Or don't worry.
Well, it's more of a variable force, so it's got to be less.
2.
That's right. So 0 would be
Wrong. So
in this interval as well. So if I check 1, does 1 work?
No.
1 minus 2 is greater than 5. No, that is not true.
So it would just alternate, right?
They just alternate. If you want to check, you got to figure out what 1 plus square root of 6 is, or something close to it. Let's see. You could check 4, or you could check 10 if you just wanted to be real sure. But you could also just alternate. So interval notation is going to look kind of ugly with the square root stuff in there.
Too bad.
Negative infinity to 1 minus root 6. 1 plus root 6 to infinity. The alternate, I shouldn't say alternate, the other way to do that with the graph, this is a parabola that's pointing up. You found the 2 roots, so it would look like this. And so where that parabola is greater than 0 is there and there. So whichever sort of method you want to use, you got to find the zeros, you have to put them on a number line, and then how you test the intervals is either graphically or numerically. I guess we'd phrase it that way. Negative b over 2a is the vertex. Yes, you must be on the graphing. Do we want to go back and do one of those? Hey, 2 looks easy because it's in vertex forms. That's kind. So should I do one of 1 through 4? Let's go backwards and do one of those again. Let's do number 4. So let's see. That would be. How do you want to do number 4? We've got options now. Okay. Negative b over 2a. Would be negative 4 over 2 times 2 is negative 1. That's nice. So 2 minus 4 is negative 2. And then be careful, it's not 1, 1, 2, 4 because of that 2 on there. So 1, 2 on either side. and 2, 8 on either side. Solid or dashed line? And then am I shading above the parabola or below the parabola?
Above.
Solid and above. That means any point in that region will work. By the way, the testing the point thing works on these as well. You could pick a point inside the parabola and see if it works, and then pick a point outside the parabola and see if it works. But it's easier to just use the shade above, shade below thing. Okay, so your assignment is the rest of these, not just the odds today, because we did a whole bunch together. And just remember that due Friday are the first 2 worksheets. Worksheet 4-6 and worksheets, whatever the next one was, 4-3 to 4-6. And I will happily take that today if you're done with it and want to turn it in and be done with it.